Alright, in this video we're going to be going through the solutions to the in-class inclining problems 1 through 12. So, problem 1. You're planning an inclining experiment. How large of weight will be required to create a four-angle list if the vessel's displacement is 8,900 tons, estimated GM is 6 feet, and the distance the weight can be moved off the center line is 33 feet. Okay, so in this problem, we're going to be starting off with our formula for the inclining experiment. All right, and we're going to be doing problem 1. So our formula for the inclining experiment is GM equals weight times distance over displacement and times the tangent of theta. Okay? Now, in this problem, we're trying to solve for a weight. Okay? So, this weight here. So what we've got to actually do is we've got to rearrange this formula and solve it for weight. So, we're going to have to multiply both sides by displacement tan theta. Okay? And then divide both sides by distance. And what we'll end up with is weight equals GM displacement tan theta divided by distance. Okay? And that's the formula we're going to use to solve this. And so if we substitute values in here, our weight is going to equal, well, let's see, what's our GM? From the problem, they give us a GM of 6 feet. Okay, so that's 6 feet times our displacement, which is 8,900 tons. Okay, times tangent of the angle, and the angle is 4 degrees. Oh, excuse me. Let me just put the angle in. Okay, of 4 degrees, and that's all divided by the distance, which is 33 feet. And when you do that, you're going to end up with 113 tons. So that's the answer to problem number 1. All right, so now let's do problem number 2. So in this case, we have a vessel inclined by moving a 40-ton weight a distance of 23 feet from the center line. All right, 12-foot pendulum shows, this is the inclining experiment. Okay, so we got our deflection, hydrostatic property, so came to be what is the kg? Okay, well, for this problem, let's calculate our GM. Okay. We'll calculate our GM, and then we're going to subtract our GM from our KM, all right, and that'll give us our KG. Okay, so we're going to do this in 2 steps. So here we go. Let me just write, excuse me a second. Oh, wait a second. I can do this, right? All right, learning some new software here, folks. So, step 1. Okay, so step 1 in this is going to be to calculate GM using the formula. And then step 2 will be to calculate kg. Okay, which will be km minus kg. So let's do step 1. So we're going to use our same formula here again. We've got GM equals weight times distance over displacement tan theta. And so for us, that's going to equal 40 times 23 divided by 8,150. Okay, and probably the trickiest part of this whole problem is what's coming up next. So we have the tangent of theta is going to be equal to a ratio in this case, which is 9 inches, okay? 9 inches divided by 12 feet, okay? So because we have a deflection of 9 inches on a 12-foot pendulum, and tan theta, another way of saying that is GG over G, or the deflection of the pendulum divided by the length of the pendulum. But now the tricky part here is that we have inches and feet, so I got to get rid of I'm going to multiply this by 1 foot for every 12 inches, okay? And when I do that, actually, I'm going to end up getting rid of all my units, okay? And when I solve that, okay, I'm going to end up with a GM of 1.8 feet, okay? Now that I have my GM of 1.8 feet, I want to get my kg. Well, kg is going to equal km minus gm. So that km is given to us in the problem. It's 29.06 feet. 29.06 feet. And we're going to be subtracting 1.8 feet. And when we do that, we get a kg, okay, kg equals 27.3 feet. All right, and that is the solution to problem number 2. So let's go on to problem number 3 now. All right, we'll come back up here. All right, so now we're going to do problem number 3. So problem 3, vessel displaces 15,000 tons. Tank whose center of gravity is 14.5 feet from the center line is flooded with seawater. The dimensions of the tank are length, Okay, this is going to be a multi-step process here. So in this case, let's see. What is the angle of list caused by flooding this tank? So we're going to have to do a couple things. First of all, we're going to have to figure out the volume of that tank. Okay, so all right, we need our formula here. So we have GM equals weight times distance over displacement tan theta. Okay, but in this case, we want to actually solve for list. So what we're going to do here is we got to get the tan theta all by itself. So we're going to multiply both sides by tan theta, and we're going to divide both sides by GM. So we're going to end up, as we rearrange this formula, it's going to be tan theta equals weight times distance over displacement GM. But now we've got this tan we've got to deal with because we want to get theta all by itself. So we got to do the inverse tangent of both sides. So if we do the inverse tangent of both sides, we'll get rid of the tangent on this side. So that's theta equals tan to the minus 1 of weight times distance over displacement GM. So that's the formula we're going to have to use. It's this formula just rearranged to solve for theta. Okay? So now, so we start off at 15,000 tons, but now we're going to flood this tank. So you have to figure out what the volume is of that tank. And then we can add that volume of displacement to this, and that'll give us our overall displacement here. And otherwise, these numbers are given to us in the problem. So let's figure out the volume of that tank. So that is a rectangular tank. So volume is going to equal the length times the width times the height. So in our case, the length is what is it? It's 45.26 feet. Okay, so that's 45.26 times 29 times 4, and that all equals 5,250, 5,250.2 feet cubed. Okay, but that's cubic feet. We gotta get this into tons. So now we're going to have to take that volume, and weight equals volume times tons for cubic feet. Okay. So in this case, our volume is 5250.2. All right, that's feet cubed. Okay, feet cubed. And in our case here, it's 1 ton. It's seawater. So it's 1 ton for every 35 cubic feet times 1 ton for every 35 feet cubed. And you can see the feet cubed cancel out. And when we do that, we're going to be left with our weight is going to be 150 tons. So that's the displacement of the amount of flooding that we just did. Okay, so now we're ready to solve the final part of the problem. We're going to go back up to our formula here, okay? And we're going to substitute all these values in here. So theta equals tan to the minus 1, the inverse tangent of the weight, which is now 150 tons, times the distance, which is 14.5 feet, divided by the displacement, which is now going to be 15,000 plus 150, and that's going to be multiplied by our GM, which is 2.2 feet as given in the problem. And we do all that, and we do the inverse tangent of that as well. We get a theta of 3.7 degrees. So that was problem number 3. Okay. Let's see what we've got here. Now we're going to do problem number 4. So, problem 4. All right, here's going to be the solution for problem number 4. All right, so let's see here. Vessel is inclined by shifting away to 50 tons, a distance of 20 feet from the center line. 15-foot pendulum shows a deflection of 10 inches. Displacement is 8150, including the inclining weight. What is the kg of the vessel? All right, well, we're just going to do our GM formula again, and then we'll calculate kg by doing km minus gm. So let's do it. So GM equals weight times distance over displacement tan theta. So our GM is going to equal our weight here in this problem is 50, and that's times 20 divided by our displacement, which is 8150. And the okay, now we can add, we don't have the angle, but we do have the ratio of the deflection to the pendulum, and that's the same thing as tan theta. So what we're going to do now is we're going to put all that in here. So that's going to be 10 inches. Okay, that's our deflection, divided by 15 feet. And we have the same problems we had before. We got inches in the numerator and feet in the denominator. So we got to multiply that by 1 foot for every 12 inches, and all of our units go away. And now our GM, when we solve that, it's going to be 2.2 feet. And our kg is going to equal km minus gm. And our km is given to us as 30.1 in the problem, 30.01, 30.01. minus 2.2, and we end up with a kg of 27.8. And that is the kg for that problem. Okay? So that was problem 4 there. Okay. Well, now let's move on to problem number 5. So we'll just do problem 5 over here. All right. So using the question from problem 4, if the weight was 45 feet above the keel, what is the true lightship? So in problem 4, what we did was we calculated the kg of the vessel. But really what we're trying to get here, okay, what we're trying to get here is the kg of the lightship. Well, the problem is that we've got 50-ton weight that's not part of the lightship, that's part of the displacement of this vessel. So now we've got to remove it. All right, so we're going to use theory of moments to get rid of that. We could also use GG if we wanted, but one way or the other, we got to get rid of that. And I think we'll, wait a second, let me just bring this back up. Here we go, perfect. Okay, so we're going to do this by GG. We're going to subtract 50 tons. That's at a height of 45 feet above the keel. So we know that GG, the shift of G, is weight times distance over the overall displacement after the fact. Well, the fact is that we're going to be discharging 50 tons. So we're going to have to subtract 50 tons from the overall weight of the vessel, which from the previous problem was 8150. So we're going to be subtracting 50 tons from that. So let's just stick some stuff in here then. So we're going to have our weight is 50 tons. That's what we're removing. And our distance is 45 feet. And our displacement is going to be 8150 minus 50, okay, because we're going to be removing that weight. And when we do all that, we should get a GG of 0.11 feet. Now, we're discharging that weight from high up on the vessel, so that means G is going to go down. Okay? Well, what was our kg at the beginning of the problem? Well, our kg from problem 4 was what? 27.8, right? So our kg of the lightship will be the kg with the 50 tons minus the GG when we discharged it. All right, so the kg is going to equal the kg that we started with the problem before we discharged the 50 tons minus the GG. So that was 27.8 feet, and that's going to be minus 0.11 feet, and when we do that, we get 27.69 feet. And that is the kg of the lightship, okay? All right, so that's problem number 5. Let's take a crack at problem number 6. Maybe I'll just scroll this back up. Oh, bring that back down a little bit. All right, oh, too far. First day with the new software. All right, just be patient with me a second. Okay, problem number 6. All right, well, now we got a 30-ton tank car loaded on deck 10 feet from the center line. 2 trucks are available to load. Okay, so we got 2 trucks on the pier, and we're going to put them on the vessel. And we want to know how far should we put them off the center line so as to maintain the vessel's upright position. Okay, well, so what we need to do here is a 30-ton tank car is loaded on deck 10 feet off the center line. So we're going to assume that the G was on the center line before this problem started. Okay, the vessel was upright, and then we stuck this 30-ton car 10 feet off the center line. And that's going to create a moment that's going to incline the vessel. So first thing we're going to do is we're going to calculate the moment so here we go. Calculate the moment of the off-center weight. Okay, that's the first thing we're going to do. And after we do that, then we're going to determine the distance we're going to need. Then we'll determine the distance, okay, to load to counteract that weight or that moment. Okay? So, first thing, let's calculate the moment created by 30 tons at 10 feet. So we have a weight times distance equals moment. All right, so we have a 30-ton car, and we put it at 10 feet, and that gives us a moment of 300 foot-tons. Okay? Now, if we want to balance that 300 foot-tons, we just have to create 300 foot-tons on the opposite side of the vessel. So let's see what they told us. Oh, we've got 2 trucks to available load. One is 8 tons and one is 5 tons. So we know how much weight we're going to be putting on that thing. We just have to figure out what distance to put it off the center line on the other side to counteract the 300 tons. We have 300 tons on one side. We got to put 300 foot tons on one side. We got to put 300 tons on the opposite side, okay, in order to balance out that ship and bring it back to upright. So what do we got? We're going to have to make 300 foot tons, okay? It's going to have to equal our weight times distance. Well, we know what our weight is. Our weight is going to be 8 tons plus 5 tons. The only thing we don't know is what's the distance, okay? So we're going to have to solve for D. And how we're going to do that is we're going to add these two and then divide this side by that. So what's 8 and 5? That should be, 13? So I'm going to divide both sides by 13. So D is going to equal 300 foot tons divided by 8 plus 5, 13. And that means that D should come out to 23.1 feet. Okay? And that's the answer to problem 6.